corner delta service is a three-phase, three-wire system where one phase is grounded at the transformer. This grounding is achieved by connecting the neutral point of the transformer directly to ground. The grounded phase is designated as the corner phase. Square D QED service equipment is designed for use on corner grounded systems. The bonding provisions for the grounded phase are typically found in the main breaker section of the panel board. Expect to find a bonding screw or terminal to connect the grounded phase to the neutral bus. In some situations, an additional part or kit might be necessary to complete the bonding provisions for the grounded phase. This requirement can vary based on the specific model of the QED panel board in use. When installing QED service equipment on a corner delta system, a sequence of steps is crucial. Firstly, install the main breaker. Ensure the main breaker is appropriately sized for the intended load. Secondly, connect the service conductors to the panel board. These connections must be made to the corresponding terminals within the main breaker section. Thirdly, connect the grounded phase to the neutral bus. Employ the bonding screw or terminal to establish this connection. Fourthly, install the branch circuit breakers. Each branch circuit breaker must be correctly sized for the specific loads they will serve. Fifthly, after completing the installation, thoroughly verify all connections are secure and the system is operating as expected. Important considerations when working with the corner grounded delta system include wire identification. The grounded phase should be identified with a white or grey wire. The remaining two phases should be identified with black or red wires. The neutral conductor, if present, should be identified with a green or bare wire. Adherence to all local electrical codes and regulations is paramount when installing any electrical equipment. Ensuring proper grounding and bonding in a corner delta system is crucial for safety and proper operation. The grounded phase acts as the reference point for the system, helping to stabilize voltage and provide a path for fault currents. When a fault occurs, such as a short circuit to ground, the fault current will flow back to the source through the grounded phase, tripping the circuit breaker or fuse and interrupting the flow of electricity. This protects equipment and personnel from electrical hazards. The size of the grounding conductor is determined by the size of the service entrance conductors, and the applicable tables in the National Electrical Code, or NEC, provide guidance on this. Correctly sized grounding conductors are essential for safely carrying fault currents. The bonding connections within the QED panel board ensure that all metal parts of the enclosure are electrically connected to the grounded phase. This creates a low impedance path for fault currents, minimizing voltage differences and reducing the risk of electric shock. Proper bonding is particularly important in older electrical systems, where the grounding infrastructure may not be as robust as in newer installations. Carefully inspect all bonding connections to ensure they are tight and free of corrosion. The main bonding jumper, which connects the neutral bus to the equipment grounding bus, must be properly sized and installed. This jumper provides the primary path for fault currents to return to the source. The location of the main bonding jumper is typically specified by the manufacturer of the QED panel board. In some cases, it may be necessary to install additional grounding electrodes to supplement the grounding provided by the grounded phase. Grounding electrodes, such as ground rods or ground plates, provide a direct connection to the earth, helping to dissipate fault currents and stabilize voltage. The number and type of grounding electrodes required will depend on the specific site conditions and local electrical codes. When working with a corner grounded delta system, it is essential to use appropriate personal protective equipment, or PPE, including safety glasses, insulated gloves, and arc flash protection. Always energize the electrical system before working on it, and verify that the power is off using a voltage tester. If you are not qualified to work on electrical equipment, consult a licensed electrician. Understanding the principles of corner grounded delta systems and the proper installation and bonding techniques for Square D QED panel boards is essential for ensuring the safety and reliability of electrical installations. By following the steps outlined above and adhering to all applicable codes and regulations, you can help to protect equipment and personnel from electrical hazards. Furthermore, the identification of the grounded phase with a white or grey wire and the other phases with black or red wires facilitates easy recognition and prevents accidental misconnections. The green or bare wire used for the neutral conductor, when present, further aids in maintaining proper wiring practices. The NEC contains specific requirements for corner-grounded delta systems, including conductor sizing, overcurrent protection, and grounding electrode systems. Familiarizing yourself with these requirements is crucial for ensuring compliance with electrical codes and standards. Additionally, continuous education and training on the latest electrical technologies and safety practices are essential for staying up to date and maintaining a safe working environment. Square D provides detailed documentation and support for its QED panel boards, including installation manuals, wiring diagrams, and technical bulletins. Consulting these resources can provide valuable information and guidance for installing and maintaining QED equipment. Regular inspections of electrical systems, including corner-grounded delta systems and QED panel boards, are essential for identifying potential problems and preventing electrical hazards. Inspections should include checking for loose connections, damaged wiring, corrosion, and other signs of wear and tear. Any issues identified during inspection should be promptly addressed by a qualified electrician. Moreover, when working with three-phase systems, it is important to understand the phase relationships and voltage characteristics. In a corner-grounded delta system, the voltage between the ungrounded phases is typically the same, while the voltage from each ungrounded phase to ground is different. This can be a source of confusion, so it is important to carefully measure and verify voltages before working on the system. Also, power quality issues such as voltage sags, voltage swells, and harmonic distortion can affect the performance and reliability of electrical equipment. Monitoring power quality and implementing appropriate mitigation measures can help to prevent equipment damage and downtime. Power quality monitoring devices can measure voltage, current, frequency, and other parameters, providing valuable insights into the performance of the electrical system. Harmonic filters and other power quality mitigation devices can reduce harmonic distortion and improve voltage stability. Ground fault protection is another important safety feature to consider in corner-grounded delta systems. Ground fault protection devices such as ground fault circuit interrupters, or GFCIs, and ground fault relays can detect small amounts of current leaking to ground and quickly interrupt the circuit, preventing electrical shock. GFCIs are typically used in residential and commercial applications, while ground fault relays are used in industrial applications. Surge protection is also important to protect electrical equipment from voltage surges caused by lightning strikes, utility switching, and other events. Surge protective devices, or SPDs, divert excess voltage to ground, preventing damage to sensitive electronic equipment. SPD should be installed at the service entrance and at individual equipment locations. Furthermore, energy efficiency is an important consideration in modern electrical systems. Energy-efficient equipment, such as LED lighting, variable frequency drives, and high-efficiency transformers can significantly reduce energy consumption and lower operating costs. Energy audits can help to identify opportunities to improve energy efficiency. And also, renewable energy sources, such as solar and wind power, can be integrated into corner-grounded delta systems to reduce reliance on fossil fuels and lower carbon emissions. Renewable energy systems require careful planning and design to ensure proper integration with the existing electrical infrastructure. Battery storage systems can also be used to store energy from renewable sources and provide backup power during outages. Finally, smart grid technologies such as advanced metering infrastructure, or OMI, and distribution automation can improve the reliability, efficiency, and security of electrical systems. AMI allows utilities to remotely monitor and control energy usage, while distribution automation enables automated switching and fault isolation. These technologies can help to optimize the performance of corner-grounded delta systems and improve the overall resilience of the electrical grid. In summary, corner-grounded delta systems present unique challenges and considerations for electrical installations. A thorough understanding of the system characteristics, proper bonding and grounding techniques, and adherence to applicable codes and regulations are essential for ensuring safety and reliability. Continuous learning, regular inspections, and the implementation of advanced technologies can further enhance the performance and resilience of these systems.